Hi, I'm Maxine Bingham from IBM System Networking. I'd like to welcome you to our webinar about taking your network from bottleneck to breakneck with software-defined networking and Openflow. SDN is one of the most exciting developments in enterprise networking, some say for decades, and we're glad you could join us to learn more about it. Our knowledgeable presenters include Stuart Raphael, Business Line Executive for IBM System Networking, and Don Clark, Director of Business Development from NEC. We're also delighted to have as our guest speaker an SDN expert, Andre Kindness, Senior Analyst with Forrester Research. At the end of the presentations, we'll be having a question and answer period. You can type any questions into the Q&A widget at any time. You'll also be getting an email with a link to the webinar replay from which you can download the slides so that you can recapture what was said here today. To start our webinar, I'd like to turn this over to Andre Kindness of Forrester Research. Welcome, Andre.
Thank you, Maxine. It's a pleasure to be here today, and I appreciate everyone taking time out of their busy schedule to attend this webinar. I serve the infrastructure and operations professionals, and specifically in the networking space. Even though I've been putting networks together for almost 20 years, my degrees actually I got started in was engineering, aerospace, aeronautical engineering. And I started off in the aircraft industry before I moved over to officially networking. Really, to be honest with you, it got started when I started stringing Cat5 cables across the manufacturing facility. So I could, instead of walking across the facility and handing floppies of new changes in the bill of materials, I could, zoom them across without having to waste my time. And unofficially was also so 4 of us could play Doom at lunch. Of course, at lunch, right? We didn't do any other time. But working at this small company gave me a really unusual perspective about customers' needs. And in itself was the fact that if you really take a look at, if we had network engineers designing aircraft today, we'd have something very similar to this. We'd have the fastest, most powerful passenger planes in the world. Technically, as an aerospace engineer, I can tell you there's nothing wrong with this design. With big bypass fan ratio to jet ratio, this engine could push the greatest amount of airflow through the aircraft itself and to the engine. Basically, air packets through the turbine. However, it wouldn't be very comfortable for the passengers with the wing flex and the vibration. And don't get me started about the wasted capacity of the plane itself. It's the same thing within networking itself. You know, we talk about 802.11 AC, 40 gig, 100 gig. We need to stop thinking about speeds and feeds and focus on really what's going on, about workloads, and ultimately what's going on with the user. Yeah, we need to deliver packets. Don't get me wrong about that. That's not the issues that we run into the most with clients themselves or most infrastructure operations teams are dealing with. Most infrastructures don't use the total bandwidth they already have. And this is what I wanted to talk to you today about. We can't keep on going down this same path. What I'd like to do is spend the next 25 minutes with you sharing the future of networking. But what we're going to do is start off on the high level and start off on the business level itself. And I know a few of you are growing out there, why is he talking about business? But the reality is that business is really setting the agenda of what's going on with infrastructure and operations, and specifically in the networking space. So you can see number 1 on the agenda list for most business decision makers, over close to 4,000 of them is, cutting costs. And that has not changed in the last 5 years. Even IT cost is on this list itself. But surprisingly, look at position number 2, number 3, and number 4. It's not about cost. What's going on with a lot of businesses is they're realizing that, yes, cost is one aspect, but they also need to deliver products and services to generate revenue. And this is what's changing within businesses themselves, is the way they're starting to do it. They can't do it on a high volume, low cost basis anymore and really compete in that aspect. What they're doing is actually changing the way they want to come to market and the products and services that they want to offer. And what they're doing itself is really starting to look at what Starbucks has done. It's taken a commodity type of material, coffee beans itself, and now you pay pretty much, if not 10 times, 100 times more than your grandparents paid for a cup of coffee. And people are realizing that, and organizations are realizing that if you create a product that's dedicated to the individual, that you customize that product and that service, you can charge a lot more. And why? Well, people feel like that business is delivering a product to who they want and what they want in their life at that moment in time. And they'll keep on going back to that type of business. And you're starting to see this across the industry itself. I mean, people even at home now have, if you're in Europe, Nespresso, if you're in the U.S., it's K-Cups, be able to have your own type of coffee at home. Even Adidas, Nike, they offer the capability of creating your own shoe. So you can really show the world who you are. And you go back to that company and say, you know what, I want another product from you because I know that you understand who I am. And this doesn't apply just to the world of business to consumer itself, but really it's even happening from business to business. You think about Roche Personalized Healthcare and what they're doing in that aspect. In their filings for 2011, every single page on their filings showed at least 4 to 5 times they talk about personalized healthcare. It's interesting. You're like, well, and most people would think a company that's pharmaceutical and medical goods are selling to the healthcare industry, why would they care about personalized healthcare? In that sense of what they're trying to do is understand their consumers so they can offer more services. They can have a better response to what they're ultimately who their customer is, which is the actual consumer themselves, even though that they're selling to the healthcare. So they want to understand all the way to the end person what they're trying to do. And ultimately that is itself is to better understand the customers and what they're doing, and so that they can charge more money for the products and services that they're offering, that their gross margins are larger. And so you're starting to see organizations and companies really think about offering products and services around having what the individual customers need. Now this changes what happens with IT. This changes the infrastructure and the dynamics of the infrastructure. Campus environments are getting smaller. There's more branch offices, more people working from home. Why? Because when you want to offer customized products and services, you need to be closer to your customer to understand it. You take a look at the banking industry. Now they have, their banking centers within grocery stores, so they can be part of the customer's life. So they get the groceries and out the door, they're in the part of the customer's life of what they're doing that day. And you're seeing that all over the world in what is transpiring with people offering more customized products and services. And so as your resources become more spread out, a few other things start to change on the infrastructure itself. The fact is now you want to connect these people together and your resources together, and you start to see video, you start to see voice go across these environments. And so it changes what happens to the network connections, and everything doesn't go across the LAN, it's going across LAN, WAN, and wireless LAN. There's a lot of different changes in the dynamics of the actual traffic itself. And as people get spread further and further away from their campus office and further away from HR and further away from IT, they feel empowered. They need to get their jobs done, and so they're looking at the tools around them to get their jobs done. You take a look at 78% of kids coming out of school today, college today, will choose the job that they want based on being able to bring their own device to work. In this economic times, that's a surprising statistic, an alarming one. Even 40% will do it whether the IT organization supports them or not. So now you have this very dispersed employee who's using outside tools to get their jobs done, whether it be iPads or their phones, whether it be something as a SaaS provider, you're using Gmail or Dropbox, because they realize that they don't have access to everything they need, and they need to get their jobs done, and they're going to use whatever's around them. And this doesn't even apply to the resources, but even infrastructure and operations teams. You look at the app developers. In 2009, less than 10% would consider using infrastructure as a service. 2010, it jumped up to 33%. In 2011, we saw the numbers jump up to 70%. And we predict the next few years it'll be close to 99% feel comfortable using infrastructure as a service outside of there. People want to be empowered. You have an infrastructure has to support a very mobile, a very dispersed, and very empowered type of client out there. Now, so what you end up seeing in itself is you have this environment where you have users moving around and security services and policies have to follow them. But in the same vein, on the other side of the infrastructure, within that data center, you have the exact same thing happening. It's a mirror of itself. You have applications and data moving itself around from data center to data center, or they can be going out to cloud services and leveraging out there. And so your users who are very mobile and empowered are moving around in the VMs and data are moving around. You have to connect these things together. You think about from a networking perspective, no longer are you funneling everything back to a data center and everything residing in this Fort Knox area. Data could be floating around everywhere. You could be offloading straight from the branch office to a closest SaaS provider. And so you have this environment of this flows of this data, of these VMs, of these users being very dynamic and changing all the time. Now here's the issue of what's going on with that. We're not designed for that type of environment. If you think about, as a networking professional, I would say that you're not going out there and changing for every time a user calls up and user goes somewhere, you're changing the network to what needs to go on. Typically, it's very, as we all know, our networks are very manually driven. Set it up, And then we hope that that's the way that needs to be done. And the way we even monitor it, it's not driven by tools and monitoring systems. Typically, those are last on people's lists when they start to have issues. We make an adjustment on the infrastructure, and then the way we find out about it, if it works or not, we change the quality of service of a VLAN, of a flow itself. If we dedicate too much bandwidth to a particular application and other is constricting the bandwidth or it's constricting the flow of other applications, we'll make adjustments to the switch or to the router itself. It's very manually driven. It's really built on the fact of ARPANET itself that we wanted to have multiple flows going across one type of device, and we wanted to make sure it was reliable. The network design included recognition it should provide for efficiency of transmitting and routing traffic between nodes. Decisions were based on links being up or down, traffic congestion, and a few other factors. But we never think about the user, the workload, or the application in that transit. We have links that are static, single pass with backups ready to go. We're not using things efficiently. What's been missing from the equation is really understanding what network is hosting. What is it connecting together? What is it trying to do other than just move packets around? We've gotten to the point of that we're much further along on this. And this infrastructure is not having the capability of being quick and dynamic and flexible to serve this world that we've transpired into. Now, that's not the only thing that goes on within there itself is the infrastructure. But think about the operations. And here's the frustrating part with a lot of organizations with their networking teams, the Kerbos of infrastructure and operations. Everybody has to go to the network because the network touches everything. And we've carved our bones on being masters of complexity. Think about the way we telnet into or do a secure shell to change configuration files, or we TFTP, we use ARP, we use OSPF to set up the network, the protocols like that. I mean, the whole idea is we have our own language and medical language basically for networking itself, and other people don't understand it. Everybody has to come to us to really put new applications on there, put new devices on the network itself. And so you're thinking about business units, servers, storage teams, clouds. Everybody has to come to the networking team to get something done. And the reality is we don't have enough resources. And so this is some of the frustration that's starting to see within businesses out there, whether it be Facebook or Yahoo or Google. And specifically, one other area that suffered some of this frustration was actually the research areas. And a perfect example of that was UC Berkeley and Stanford. If you want to do cutting edge type of research, you need to have access to the network. But here's the reality. The network was owned by not the researcher teams, but by the infrastructure and operations of those universities. You couldn't go in and cut up the network and run your own experimental protocols across it because you had to go to the networking team because only one person could get in and change the configuration files and allocate you a VLAN or something like that. But you couldn't change things on the fly. And so this became this concept of how do we have the capability of slicing up, how do we have the capabilities of empowering other groups to use the network as we need to, just as we want to empower ourselves to bring in our own device so we can get our jobs done. And so you have this concept of this group coming along who have created this idea of let's have a way to cut up the network, of software defining the network itself. And I'm going to let Stuart and Don talk a little bit more about that. But what I want to talk to you and share with you is what we're trying to do is take the concepts we've seen outside of infrastructure and operations, and the best area to really give that example is the closed-loop system within aircraft. Thank God, you take a look at modern aircraft or fighter jets today, they're not manually run, just like networks shouldn't be manually run. But today, networks are manually run. We make a change. We're a network administrator. We go in, we CLI in, and typically in a data center, you run about 250,000 command lines. So don't tell me there's not going to be an error in that data center itself when you're configuring it. You put the network in, and your system output is based on if you're having a good VoIP call. If you're getting a lot of complaints at the help desk, that's a person calling in. The help desk sends you a ticket. You start to do an investigation, and voila, you're back into this cycle. But it's a manually driven kind of closed loop. We need to get to the point of having a system that recognizes what the application needs, adjusting the infrastructure, monitoring the infrastructure for certain boundary conditions that we want to say is acceptable. And what we would use is user experience. And don't tell me that we can't use that because we have MOS score today, which is a subjective feeling that gives us an objective result in the end. And so why not have that kind of built into the system, an automated system? And if we can model airflow and all the types of flow in 3D for aircraft, we can certainly start to model flows of traffic and be able to adjust the network based on that itself. And so then what you have is this capability of this concept of software-defined networking, of why do we have all these people, basically all these brains sitting out there within the network itself, and basically what we have to do is give a policy to each one and configure each one. In this concept of what Berkeley and Stanford tried to do is say, you know what, you have to set policies up, you have to configure each one up individually, each one has to be done by a dedicated person. Wouldn't there be a better way of managing this network? Couldn't we do another approach of having this network be sliced up and diced up by the way we need to run it that would be much quicker? Couldn't we, in some ways, take all the intelligence out of the infrastructure and centralize it? We've done it before. Remember fat APs, everybody? Now we have this thin AP world where we've centralized the control plane, data plane into a controller itself. A lot of the vendors have them out there today. So why not have that? Take all that control planes and centralize it back to one location. And then your data plane itself becomes an executioner of delivering out what needs to happen. And the best way I like to deliver this and explain this concept is what we've done is taken the brains out of all these devices, we've centralized it so we have this operating system in the central place. And then we have this capability of sending signals down to the data plane, which is basically, we could say, is our arms and our legs executing what our brain wants to do. And this concept is called software-defined networking. And a few of you out there probably heard of the concept of Openflow. And Openflow, all it is, it's a protocol. It's the spinal column to your routers and switches to tell them what to do when they see a packet. And so what you have is a centralized brain sending through a spinal column and execution out to the arms and legs of how to execute what the body needs to do. In a sense, what is our body? Our body is this infrastructure, basically this network consisting of LAN, wireless LAN, and WAN acting together to deliver the right set of services to that individual user and being able to change things around. And this is what this direction that this industry is going. We have an infrastructure that can create utilization. We don't have to have links that are just sitting in passive mode, but it can be given back and said what's going on with them and have this brain make a decision if we want to use these links that are down to fully load them. We have the capabilities of using infrastructure that could be a commodity-based and lower our infrastructure costs itself. And even the fact is we can create an infrastructure that starts to align itself to the business, to the users, and not just to the flow. Yes, the flow is important. We've got that covered. We've been doing it for 20-some-odd years, but we need to take it to the next level and align ourselves to where the other infrastructure operations are going, and that's to the business, that's to the users, and that's to the workload itself. And so you have this concept of software-defined networking. And to give you a pragmatic view around it, a lot of you work with app development teams. Yeah, we have test centers. We have this workload test center. But when we want to create a new app, we really don't know how the app is working within that environment itself. We really need to be able to move it to a production environment. But that is a horrible experience because that requires you to either, if you configure a switch and you change the configuration of a switch, unless it's a typical, nonstop scenario, you have to reboot the switch itself and you cause users to go down. Why not be able to have the switch partition automatically or cut off a piece of it? And so you can have a switch that supports the Openflow protocol, and you can have app developers slice off part of the network so that they can put an application out in the cloud, run it through routers, and then be able to test it on the end user device and get a real life scenario when they're creating the application of what goes on there, something you cannot do in a test environment, and at the same time not affect production traffic. And this is what the concept of software-defined networking has tried to bring to the table itself, is how do you slice and dice up this infrastructure so it starts to cater to the different groups out there. It starts to cater to the app teams. It starts to cater to the business. It starts to cater to the storage team that needs certain pieces of it, or the video team that needs certain pieces. I'm sure quite a few of you out there are freaking out in the fact that then that means someone's going to take over and they're going to cause problems. You know what? The reality is that we're heading toward the path of things need to be working together, and you have to start empowering other groups. And you can't do it by just holding on to everything. We don't have the resources to keep ourselves in technology silos. We need to move ourselves from this artisan types of creating cars, creating networks, to one that's much more consistent, what we're seeing in manufacturing today. In manufacturing today, you can get lots of different types of cars off the assembly line. It's just But at the same time, it is very automated. It's very consistent in what it delivers. And so we're heading down this route of having a network not be a separate entity, but be part of the server, the storage, the device infrastructure, and that you have the capabilities of having this infrastructure that's driven by complex analytics, policies of the business itself and the governance of the business, feeding into a configuration, a management tool that adjusts the underlying infrastructure. And then you have a monitoring system to monitor and readjust it, much like you see in the closed-loop infrastructure today. Now, it's more than just technology. And what I wanted to leave you off with was, yep, there's a lot of things going on out there. You can go out and buy the technology. But I want you first to think about and set yourself up for success on embracing this new technology that's coming along, this new direction that's going. And one is really, and I know a few of you probably are like rolling your eyes about strategy. But when it comes to automation, when it comes to empowering other groups, we have to set standardized process and procedures, roles, and responsibilities. And that's often the biggest hurdle for people to overcome. Because otherwise, if you don't, and you have a lot of variances, then you become bogged down with one-offs all the time. We get back into running things in a very manual mode. And the reality is we're all competing for our jobs today. There's companies are outsourcing more and more their IT department. There's cloud providers coming along and offering services. We are now in competitive position for our jobs, and we need to start delivering quality and delivering speed on what goes on there. And the only way we can do that is start off with a strategy that starts to standardize process and procedures, and then you should start to measuring when that goes on, changes, so that you can prove that you're a value-added asset to the organization itself. And even people will change. You know, the fact is, the reality is, yeah, you might need some CLI skills, but we're going to move to a world where you'll be taking on other responsibilities and understand coding, for example, because you'll have Java, you'll have environments where you're running Python or SOAP, that you'll need to have information go from north and southbound, needs to exchange with orchestration systems so the automation can take hold. And so you'll start to see even network engineers take on a software development role within the organization itself. And even one of the big things really to get this started is a lot of networking personnel feel uncomfortable with this new virtualized world. The reality is it's going to be about the physical and the virtual interacting, a hybrid world interacting together to deliver the right set of services. And we need to not have another team manage the virtual switch or a virtual firewall. Those are all things that we typically do as engineers, network engineers, and we need to embrace the virtual instances as well as take that under our roles and responsibilities. In the technology piece of this, don't try to own everything. Embrace and empower other teams to get their jobs done. A perfect example in the DDI world, DNS, DHC, and IPAM world. You don't need to hand out IP addresses to every group. Why not allocate to a server team a certain bunch so they can go in and grab whenever they need instead of you having to allocate it out? The same thing. Find the tools and materials that help you empower other teams so that you can go off and create better types of networking infrastructures to serve it out there. And remember, it's more than just layer 2. It's more than layer routing and switching. We're going to have security servers, business acceleration like load balancing and WAN optimization be part of accelerating the traffic and controlling the traffic itself. And so it is going to be about layer 2 to layer 7 and having this world interact together, having this software-defined infrastructure cater to the business and the users that are occurring out there. So what I want to do is hand this over to Stuart and Don to talk to you a little bit more and get a little bit more technical depth information about software-defined networking. Stuart, Don?
Thank you, Andre, and hello, everyone. Thanks for the opportunity to speak here. The subject of this webcast is evolving your network from bottleneck to breakneck with Openflow. We have an exciting agenda for you. We'll be reviewing company overviews of IBM and NEC. We'll highlight some of the current networking challenges that exist. We'll present some of the Openflow issues that create breakneck networks and focus on some of the business benefits that clients receive. We'll also share some of the use cases, and then we'll talk about some of the commercially available products from IBM and NEC. IBM system networking products and platforms connect servers and storage with high-speed and intelligent network fabrics. And the goal here is really to flatten and converge the network to improve the economics of the data center. IBM takes an open standards-based approach to this in that we implement this in some of the latest advances in data center networking technologies. We use advanced virtualization awareness to reduce cost and complexity, whether you're deploying physical or virtual data center infrastructures. We also provide a very simplified management solution in terms of being able to make the network much easier to manage and deploy, maintain, and scale. With about 14 million Ethernet switch ports connecting servers, storage, and core networks, IBM System Networking has emerged as one of the foremost and innovative leaders in this space. Don?
Thank you, Stuart. I'm Don Clark, Director of Business Development for NEC. NEC provides a complete line of infrastructure for cloud environments, from servers to storage to infrastructure software, and now with the software-defined networking line called Programmable Flow, we can provide complete solutions for our infrastructure customers. These infrastructure pieces are added to provide some of the solutions to common network challenges that customers are seeing today. In the traditional model for deploying a network for a data center, we optimize within silos. And this has had the advantage of being able to be fully isolated between the silos for security and performance. But there were a number of disadvantages to this model. It's inefficient. Resources can't be used across that infrastructure. It's complex because each one of these devices needs to be configured individually, which makes us slow to respond to new services, and it's static. Once the configuration is done with the network operators say, don't bother me, the network is running fine. What we need is a total IT and network optimization, where just like on the compute side, where infrastructure is now fungible and applications can move around for their best suited place in the data center, we need an infrastructure that is virtualized in the same way. This new virtualized network infrastructure is optimized because we can use all available resources, like Andre described. It is simple because we don't have all the complexities of the interactions of each device working with each other. That provides us more agile resource deployment and a focus on policy rather than on configuration management. And it's dynamic. With this new infrastructure, we can now manage the network dynamically through a central API. Stuart?
Now, traditionally, we've gone for more performance and scaling by adding new protocols. Today, it's adding ECMP, Trill, EIGRP, or ISIS for multipath. But these protocols add more design and configuration complexity, so that it takes longer to deploy new services, and the design and implementation cycles tend to be hard, and troubleshooting becomes even more difficult. Compounding these pain points even further are the fact that we have workloads that are unpredictable, and we have applications that are tied to the constraints of the physical resources of the network. And we also have costly appliances that are underutilized. And in many cases, the topologies that are they're really unable to adapt because they're architected to the application requirements. Let's talk about some of the Openflow breakneck network issues that we can solve. Don?
Using software-defined networking, we can move to a new paradigm of networking where, as Andre described, we move away from a traditional network model where each device has its own brain to a model where the application of the network gets moved up into the application stack, and the underlying infrastructure just becomes the fast-forwarding plane for packets that move across the network. All the programming is done up in the operating of the application stack, and each of the devices are programmed by the application so that we get a harmonized and real-time view of what's going on in the network. NEC and IBM solution combines both the infrastructure from NEC and IBM and the control capabilities of the controller to provide a new capability within the network. The new capability uses the Openflow protocol to subject rules in the network that force actions for each device. The controller has a complete view of all of the network elements and can automatically make changes dynamically based on policy. Stuart, you want to introduce SDN and the ONF?
Sure. The ONF was actually an organization of which IBM and NEC are inaugural members of, established in 2010, and it represents some of the largest data center operators in the country as board members. They really wanted to see a more open, standards-based way of approaching networking problems, the same way that occurred 20 years ago in the server industry. You may know that the ONF has now released a standard protocol among all vendors, Openflow 1.3. So this will be a standard that will come to market, and it's a very significant achievement because all of the members of the community were a part of that aggressive push to standardize across 1.3. Don?
And we can see that this is not a future endeavor, but a real endeavor. NEC and IBM, together with other partners, demonstrated at Interop how this new application model can work, where the underlying infrastructure was composed of many vendor switches, with NEC providing the programmable flow control, and other applications using the control of the network to provide new services. This demonstration shows that advanced services like multipath can be delivered seamlessly across a multi-vendor environment. Really, it's a major change in the way we can think about bringing together new networks. Now we'll turn to the business and client benefits we've seen in deployments of programmable flow and SDN networks.
With Openflow, what we've done is eliminated some of the traditional layer 2 challenges with utilizing network elements. We're not running spanning tree in the network, so we could effectively use all of the capacity of the network. And this really improves capacity consumption by over 50%. We can realize commoditization of the network by allowing customers to build logical topologies on top of their physical gear independently, so that there can be really changes to the incumbent vendor and their topology without having to make changes to the actual business logic of the organization. Openflow really enables virtualization by providing the logical layer, and we can now virtualize the network from layers 1 to layer 4. And this is independent of the traditional constraints that we saw in layer 2 and layer 3 type protocol designs. We're actually also able to do location-free appliance pooling to provide new services on demand and reduce time to market by providing those services. We could also highly utilize servers, firewalls, and load balancers because we've eliminated the traditional bottlenecks of layer 2, layer 3 networks. We also see significant OpEx improvements with Openflow because we can automate network provisioning. This saves us on professional services costs, and it also increases the speed at which you can provide new services. So by decreasing the network complexity and reducing troubleshooting time, we'll get significant reductions in OpEx. The other piece of that is that we can reduce power consumption in the network by scaling out our topologies and being able to idle switches and servers by migrating flows from areas of the data center that are not actually in use. And this is really done in a very proactive way.
An example of that is Nippon Express. Nippon Express deployed Openflow-based solution, and what they found was they were able to support some of the underlying infrastructure that they were building out on the compute and storage side with a network that was virtualized. By deploying first in their backup data center, the Openflow solution, and then moving to their complete solution, they were able to achieve a 32% annual return on investment, increased agility where their ticket time moved from 2 months to 10 days, and much greater visibility and control over their network.
An organization that is a maker of high-speed messaging appliances known as Tervella actually uses systems and appliances for global trading, risk analysis, and e-commerce, as well as big data. And what they did was benchmark the IBM and NEC Openflow solution against traditional layer 2 switching, and they found some key benefits. Openflow afforded them deterministic latency. They also saw that there was predictable network performance because they can now assign policy to network-based flows. And also, when they did some link failure recovery testing, they found that Openflow networks converged a lot faster than traditional layer 2 and layer 3 networks.
Now let's turn to some of the use cases of a software-defined network. As a complete network fabric, software-defined network provides a way to address a number of challenges most networks face, from the complexities of VLAN, subnet, and ACL management to VM migration and integration with appliances. The solution with a SDN network fabric allows a single point of view for design, deploy, manage, and monitoring entire networks, automated service provisioning through a single API, a multi-tenant network fabric, fine-grained traffic control so that we have fine control over how the traffic moves across this network, and customers can find enormous cost savings. A way that this network gets utilized, an example of that is through OpenStack. OpenStack is a model for managing a complete data center solution from server virtualization, storage virtualization, and network virtualization. Using the software-defined networking model, we can virtualize networks so that we can provide tenants within the same infrastructure, fully isolated, fully secure network services on demand. This new virtual model allows much more agility than managing the traditional VLAN, subnet, and ACL approach. Another application is network appliance service layer. In this model, we can overlay the existing network to provide service agility and still have network reliability. By connecting a software-defined network to the appliance layer of a network, we can expose network appliances as services and provide fine-grained traffic control and high throughput for those services. Stuart?
The platforms that we actually have available for Openflow afford us the opportunity of creating dynamic high-performance networks. And these networks can be implemented today with commercially available product. Presented is the IBM Rack Switch G8264, which is an Openflow switch supporting the Openflow 1.0 standard. The Rack Switch has 48 ports of 10 gig and 4 ports of 40 gig. The 40 gig ports can also be split into 16 10 gig ports with a breakout cable. So in total, 64 ports of 10 gig are available, and you're provided with front to rear or rear to front airflow and cooling. And this top of rack switch also has all of the data center features you'd expect in a switch of this kind, featuring layer 2 and layer 3 capabilities. As you've heard, Openflow is a technology that consists of really two main components, the switch into which the flows go and the controller that programs those flows. And Openflow is a new technology, but IBM and NEC has been working on it for quite a while, and we have a lot to avail you of in terms of products available today. Don, would you like to talk about the programmable flow controller?
Yeah, the NEC programmable flow product suite consists of the programmable flow switches and programmable flow controller. The PF5240 is a 48-port 1G switch with a high flow capacity, over 60,000 full 12-tuple flows, and the full hybrid mode, so it can handle Openflow and standard layer 2, 3 network flows on the same port. The PF6800 controller is an appliance that provides a flat multi-tenant Openflow network fabric for designing, deploying, and managing Openflow networks from a single pane of glass. This provides barrier-free VM migration regardless of subnet policy and provides a resilient multipath network for high-performance east-west traffic. The programmable flow controller provides a set of APIs that allow customers to do very fine-grained filter and redirect policies within the network and comes in a robust cluster configuration in a 2U Linux appliance.
In summary, software-defined networking is fundamentally changing the way networking is being done today in very positive ways. Programmable flow and SDN are really driving business value for our enterprise clients. IBM and NEC are delivering an open and collaborative solution to address networking challenges that you experience today, and IBM and NEC is committed to helping you in successful SDN deployments.
That was great. Thanks a lot, Andre, Stu, and Don. So now it's time for our question and answer period, and we'd like to open the webinar up for that. To type in your questions, look for the Q&A widget at the lower left of your screen. If you click on that, you'll open the widget and you can type in your questions for our presenters. We'll get to as many as we can. If we're unable to get to a question right now, we will get back with you and answer you individually. Also, you'll be getting a link to this presentation, as I've mentioned, and you'll be able to download the slides after that. So, Andre, first question's for you. I've heard that SDN and Openflow is only for academia and research institutions. Can you comment on that?
Thanks, Maxine. Well, it got initially started into those areas, and a lot of it, as you remember the previous slide, was the fact that you have to go through the network administrator to really get anything done. And in the academia world, it's all about research and design and being able to test out new things. And to always have to go to one group to get your job done is frustrating. And so there is such a enthusiasm around SDN in the university community, because now they can slice up this infrastructure and do the research that they're so dependent on, and that's the way they get their money from a lot of outside organizations. But in that same vein, what you see going on is it's going out to everywhere and all the other markets out there, the vertical markets where you think of carriers or healthcare, because the reality is, as I mentioned earlier, really driving towards that customized products and services, you need to be able to have this infrastructure be able to cut itself up on the fly. And so being able to drive this type of programmability is ultimately going to flow across all the other ones. It just got started in there in the academia world, but it's only one case of many where we'll see it be prevalent.
Okay, that's great. Thank you. So the next question we have, and maybe Stuart and Don, you could answer this. What are the most important use cases for enterprise early adopters? Stu, you want to take that first, then Don?
Sure, thanks, Maxine. Essentially, if you look at what Openflow does, it automates the network in terms of being able to provide provisioning capability, and that cuts down on the cost of professional services. If you look at many of the different segments that are exploiting some of the capabilities around software-defined networking, there are things such as multi-tenancy support, the ability to do fast recovery and convergence across multiple regions of the network, building a very scalable network that allows you to handle a large number of streams over large geographical areas. Also being able to have fine-grained traffic control and capacity on demand. Don?
Yeah, thank you, Maxine. And in addition to the areas that Stuart described, we're also seeing a lot of interest in service provisioning. Today, to provision cloud services requires specific appliances or other features of the network that often require a ticket and a manual configuration on a switch or set of switches. With this new API-driven controller-based network, those services can be automatically inserted and eliminate a lot of the operational expense and deliver a quicker time to market.
So, Andre, the next one's for you again. First of all, they say thank you for your presentation. And are you suggesting that SDN is essential for providing one-to-one business services in the future? And I'm guessing that means customized solutions to make companies more competitive.
It is. I mean, being able to program the network is really the future for infrastructures themselves. And we can't deliver on-the-fly services to the right user, to the right location, to the right experience, and the right time of day. If we have to do as we do today in a ticket system, and we go in and manually change the configurations of every switch and router, application delivery controller, WAN optimizer, you name it. I mean, it's just not scalable, and already there's frustrations around the marketplace around the fact that the network isn't programmable on the fly as any work group needs or business unit needs it to be. So the reality is software is the future for networking and infrastructures.
Okay, next question we have is, would SDN interoperate with a legacy network? For example, do they have to be isolated from each other? Maybe Stu, you can take that, and then Don?
Sure. In the instances where there's a need to have integration with legacy networks, Openflow switches that are hybrid in form, where they can actually terminate layer 2 and layer 3 type sessions, as well as Openflow functionality, is something that can be done in a hybrid switch. So the ability to have options to migrate traffic across those two different domains can happen in a very seamless way.
Yeah, the NEC controller supports the legacy switch protocol support for redundancy. So on the layer 3 and layer 2 networks, we can provide fully redundant links, connections into existing infrastructure, so that the transition to an SDN can be incremental and seamless to the existing infrastructure.
Okay, here's another a very interesting question. Someone says that they work in a service provider in Mexico. They'd like to introduce the SDN vision. Is this only for data centers, or does it apply also in a carrier core or access network? And I know, Don, you talked about this. Do you want to take that? And Stu, if you've got a follow-up, please feel free.
Yes, we, in addition to the research and education, the other area we've seen a strong interest for SDN is in the service provider space, because the levels of automation and the new services that customers can receive from their service providers with this new model. One example would be the new feature NEC recently introduced with quality of service. By being able to provide end-to-end quality of service, customers can get provisioned bandwidth on demand from their cloud infrastructure for incremental changes in real time. Today, to do quality of service across an entire infrastructure is a slow, laborious process, and can't be done instantaneously. This is a new service that a service provider can now implement using this new infrastructure.
Yes, in addition to what Don said, when you consider the carrier portions of the network, the ability to drive specific flows over the network and optimize that network, maximize utilization of very expensive inter-network links, whether they're links going to various data centers for backup, Openflow affords the opportunity to really maximize those links. When you look at access for handling large numbers of virtual machines, for example, or mobility of those virtual machines, having a network that's completely aware of the virtual machines, the quality of service, the VLAN IDs, and other characteristics of those virtual machines, SDN lends itself very well to that aspect of the access network. And then when you also consider fine-grained traffic control, as I mentioned earlier, the capacity to create specific directions for traffic types is of something of flexibility with SDN and Openflow.
This is Andre. I wanted to just add in that outside academia and then infrastructure as a service or software as a service providers out there, that's actually the carriers are one of the top calls I get from in my inquiries is looking to leverage that type of technology to really offer that differentiated services for their customers. So there's an immense amount of interest from the carriers and service providers globally.
Great. So we're getting an awful lot of questions. So again, as I said, that those of you that don't get your questions answered on air, we will get back to you individually. So Andre, next for you, what specific action or actions do you recommend the customers take in the next 6 to 12 months around SDN and Openflow?
So, initially I left off with this slide and listing out the actions to take, and I would say start those in the next 90 days on any one of those things. when it comes specifically to software-defined networking and really programmability of the network is jump in there. Don't take a look around what the solutions are, but start getting your feet wet. Start getting out there and testing it. Find the biggest thing within I find is actually the people issues within the organizations. Find someone who's enthusiastic about it to be your evangelist and to get things started. And so I would hunt within the next 30 days, hunt somebody down and within your infrastructure operations team who understands the technology or understands the concept and has been a vocal proponent of it, and get them outfitted with the right resources to get going on it and start testing it out.
Okay, thanks. Interesting question. Either Don or Stu, if you want to address this, are network security measures for SDN largely the same as that for legacy network?
This is Stuart. If you take a look at the fact that you have the ability to control the network from a centralized location, this really gives you an opportunity to drive policy of the network from a security standpoint that is very orchestrated and very defined. In a traditional layer 2, layer 3 network, the policies for how those traffic flows occur are very distributed, and that makes it very difficult to create policies that are governed in a unique way. So I would say that with Openflow SDN, you have the ability to drive additional applications on the network for security, whether it's specific redirects of ACLs based on the specific types of characteristics of that traffic. This type of filtering can be done very, very easily with an SDN Openflow architecture.
And also, in addition to what Stuart said, the ability to manage the policy from a single point of management eliminates one of the largest vectors for security issues, that is misconfiguration or user error. By having this single point of where the policy emanates from, those issues can be eliminated. In addition to other features that we provide, such as multi-tenant security that is provided as part of this network.
Okay, so Stuart, I think this one is best answered by you. How can I buy the solution you're presenting today? And is IBM planning to come out with its own controller?
Thank you, Maxine. The solution is available today, generally available. IBM and NEC have built an ecosystem leveraging our Openflow and SDN capabilities. We can provide you with a 10 gigabit Ethernet Openflow switch. NEC can provide a generally available Openflow controller as well as their switches. So the solutions complement each other. What was the second part of that question, Maxine?
Is IBM planning to come out with its own controller?
Well, you can expect certainly to hear more about that in the future.
Okay, we're going to have to wrap this up. I really appreciate both the speakers and all the great questions we've been getting. So just to wrap this up, I think there's a lot of questions about interoperability. And so will your solution work with my existing switches and routers in my existing network?
Yeah, absolutely. We have a number of customers that have deployed the NEC and IBM solutions as their entire fabric for the data center. And we have as many customers that have deployed these solutions for point solutions to solve particular problems, be they service delivery, be they individual infrastructure solutions, and both work seamlessly within traditional legacy networks.
So I think as we wrap this up, I'd like to ask our presenters today if they have any final comments they'd like to make. Maybe we'll start with Andre. Do you have any final comments for our audience?
Just to know that networking to me is about the most exciting time it's been in the last 15 years, and a lot of new innovation coming along. and it's going to really change your organizations and the skill sets that you need. And so, don't wait. Start today and really get involved in the technologies that are coming out, and understand that software really will change the way networking is being done. And so, go out and look for that person or persons within your organizations that you think would be a best fit for this, and get them going on it. Don't wait.
Don, do you have any last comments?
Yeah, along those same lines, there are a number of solutions that these new tools can uniquely solve. And so a lot of our customers are starting with those early projects that help them achieve their near-term requirements while becoming familiar with this tool that's really going to expand in presence across the network.
And Stuart, we'll give you the last word.
Thank you. Yeah, software-defined networking is really changing the way that networking is done today. It offers a lot of flexibility. I encourage clients to look at the challenges that they face in their networks today, and to also reach out to IBM and NEC to help address those challenges with this new capability.
So I'd like to thank again Andre Kindness, Senior Analyst with Forrester Research, Don Clark, Business Development Executive with NEC, and Stuart Raphael, Business Development Executive with IBM System Networking. Thanks again for joining us. You will receive a link to the archives. You can download the slides, and for more information, you can come to www.ibm.com/networking and www.necam.com/pflow. Thanks again, and we appreciate having you spending time to learn how to take your network from bottleneck to breakneck with SDN and Openflow.